Tokyo?
Because, yeah, they invited us to do a study. They want to measure their nitrate and ammonium level in the aerobic tank. By the way, what's aerobic?
Air, oxygen.
Aerobic, yeah. At the gym, aerobic. You need oxygen, right? When you're working out, you need a lot of oxygen. So when we give the bacteria oxygen, we call that aerobic zone because they're really working out and eating, right? And when we don't give them oxygen, that's anaerobic. So just want to get that out of the way. So when we say aerobic tank, we're giving them oxygen, blowing bubbles to them. And we have the anaerobic tank first. Anoxic zone is kind of in between the two. So you're going to have the presence of nitrate and nitrite together because there's no oxygen, so the bugs can't really do anything except for venting off nitrogen gas, right? This right here. And then this here, when we give them oxygen, they turn ammonium into nitrate. They add an oxygen to nitrogen, so it becomes nitrate. But this is not a very typical process. I don't see this very much.
Is that used more in Europe or in the United States?
In Europe, and in places where they have more space restriction, yeah. And Tokyo, definitely, yeah.
Wow.
Yeah. I haven't seen this yet. And next one, I have seen in the East Coast more, not here. It's called upstream denitrification. So they do denitrification first, and denitrification means anaerobic. So what are the bugs doing? They're not breathing, right? So they are still consuming, but they're not breathing. So they're off-gassing nitrogen. And then they have nitrification. They're getting all the oxygen they need. So they're converting all the ammonium to nitrate. Question, where are they getting the nitrate from here?
The nitrate's from
Because this is the primary settling tank, right? So this is where your customer are giving your wastewater coming in here. You have the screen to keep off the cell phone dead bodies and bicycle. And then you have this, the primary settling tank. And it's mostly ammonia, so where do you get all the nitrate here?
Urine.
Urine. Actually here, the recirculating sludge. So you get a little peak of the nitrate. Because this is all nitrate. Yeah, in the nitrification is all nitrate. So you have this recirculating sludge. So you get a little peak of the nitrate. So if you're measuring both, you should see a nice little graph like this. And in nitrification, you see ammonia drops. And really, when ammonia drops, is there any reason to give the bugs more oxygen? No. So you can stop your blower right here. But a lot of times we don't know that's where it is because we don't measure it. Questions? Next one is the reverse, is nitrification first. So what's happening first? What's the bugs doing first?
Eating.
They're getting oxygen, they're eating off of ammonia, it becomes nitrate. So you see this big nitrate because all the ammonia has been eaten. So they reverse. See this nice little trend. And denitrification is anaerobic. So what are the bugs doing? They're kind of like, they're still working, but just not getting enough oxygen, so they're off-gassing the nitrate here. So you don't really have like a recirculating line here.
This organic carbon that's added, is that non-waste? Is it just pure carbon? Or?
It's actually alcohol, like ethanol. Because denitrification, what does it need to happen? Denitrification, what do you need? You need nitrate, right, from the upstream. But you also need
organic
food for bugs, right? So then they can do this. So that's one disadvantage. You do need to add alcohol.
Okay.
So different process has different pros and cons. Good question, though. And intermittent. I see this more in industrial applications. Where denitrification, nitrification, denitrification, nitrification. So you see your nitrate goes up and down, your ammonia tries to come down. Again, when it's here, is there more reason to give more oxygen? There isn't, because there's no more ammonia to convert. So this is vital. in controlling your oxygen and try to save money.
And most of these plants like this one, do you have continuous measurements across? How's that done?
You mean, oh, for this?
Yes,
I think
process.
you probably just put one here. If you really want to, you can put two. But most of the time, they probably care about this one. So then when it drops really low, they go, no more oxygen. And it would be nice to have two, so that way you know how much to blow, because you can tell the ammonia level drops here. Sorry, I'm blocking. Okay, one last one. It's getting very popular. It's called SBR, Sequential Batch Reactor, and it's pretty much a batch. It's a tank. It doesn't go anywhere. So they fill it up, do one thing, and then let it go again. Well, how does it go? They fill it up, and then they let it go, and then put it up, and then fill it up again. So it's one tank, right? And they're filling them over and over again. So what happens is you can see the ammonia and nitrate level here. It would be nice to know when the aerobic phase, nitrification, is dropping low. So that way you can stop blowing. So it doesn't matter what your process is, if you can have a nice graph of this, you can have a very nice control of your oxygen blowing rate. I'm gonna blow through this pretty quickly. Can you tell me how many ways we can measure nitrate and ammonia in our industry? What? No? Okay.
Well, colorimetric.
Yeah, colorimetrically. Pretty much you add a chemical. It's similar when you make coffee every morning. See how dark the coffee is, how concentrated the coffee is. So when you add a chemical that reacts with nitrate or ammonia, it turns into another color. And the color intensity is how much the ion that you're measuring is. So that's pretty much just wet chemistry. We'll call that wet chemistry. But as you can tell, it's probably very intensive and very maintenance intensive, because you're going to have tubings and chemicals on site. And most importantly, you'll have to filter your wastewater clean, because you can't have any color in it. When you have color, it's already looking at color intensity, right? So that's one way, and we also do that in the lab. And another way is, you probably heard this too, UV for nitrate, because nitrate has a double bond that reacts to UV in 216 nanometer region. So you can just have a UV sensor that only looks at 216 nanometer wavelength, and they'll tell you how many nitrate